If a is a positive real number and g of x equals 4x squared, find g of 1 over a, 1 over g of a, g of the square root of a, and the square root of g of a. Well, we notice there are really two pairs of problems here. The first pair is mixing up the order of our division. First we're taking the reciprocal of a and then we're applying g to it. In the second case we're applying g to a and then taking the reciprocal of the answer. So we should expect different answers there, and likewise the two expressions here are going to produce different answers because the square root is taken either first or second relative to the function g. Well, let's remember that if we have g of x equaling 4x squared, then g of a will be 4 times a squared. But really we just take the argument that's being inserted here for x and we replace x throughout its expression. So 4x squared becomes 4a squared. Well, now let's compute g of 1 over a. If we're working on g of 1 over a, we need to take the x in g of x and replace it with 1 over a. So x becomes 1 over a, and x was squared, so now 1 over a is squared. And simplifying, we have 4 times 1 squared over a squared, which of course simplifies to just 1 over a squared because 1 squared is 1. And now that's 4 over a squared, and we've simplified that and gotten our answer. How about 1 over g of a? Well, we've done g of a in a previous step, and so 1 over g of a would be 1 over 4a squared, and there's not much we would do to simplify that, so there's that one was actually substantially easier. Remember we said that these two should have a different appearance because the order in which the reciprocal was applied was different relative to g, and we do see that that's the case. Let's try the second two. We are to compute g of the square root of a. Well, g of the square root of a would be 4 times the square root of a squared. Now if we take the square root of a number and then square it, remember that a is a positive real number, so the square root makes sense. Then the square root squared will simply give us back our number. Let's think of a was 16, then the square root of 16 is 4, and if we square 4, we're back to 16 again. So this is just going to be 4 times a. And if we evaluate the square root of g of a, well, g of a, as we said, was 4 times a squared, so we're dealing with the square root of 4 times a squared. Now, we know the rule for square roots allows us to take the square root of the 4 and the square root of the a squared. If we have the square root of a product, that's the product of the square roots. The square root of 4 is 2, and the square root of a squared, remember that a was a positive real number, so this will simply give us a back again, and we have 2 times a for our answer. And as we saw before, the answers here with the different orders of operations are different, and that's what we expected to see.